Hello students. Now in the previous videos which we have seen about the comparison of two means of the two samples, whether they may be large samples or small samples or maybe dependent samples or the independent samples. Okay, it was comparing means. Now another one which is of the same type is comparing the variance. Okay, and that technique is also called as ANOVA, or the analysis of variance. That is what the variance. Now this in this which we have seen, the means were compared. Okay, and in this techniques the variances are compared. Okay, so now what are these means and these variances? Now variances, that means again a standard deviation and all are a part of that. Okay, now, this means, variances, standard deviations, they are kind of parameters, or they are kind of the statistics. Okay, so that is what the two statistics of the data were compared. Okay, the data was compared in the sense the mean of the two data were compared, or the variances of two data were compared. Okay, that is some parameter. The data was not compared directly one to one, it wasn't compared. Either something was calculated from that, and then that those parameters were compared. Okay, so therefore whatever these tests we have seen, and also this comparing of the means test and this, that is t test, student t test, pair test and all, and also this ANOVA test, analysis of variance, they are called as parametric tests. Why? Because in these cases some parameters, that is what this mean, variances, standard deviations, etc. are compared. The data in those forms are compared. Okay, now we are going to look at, there are something called as this non-parametric tests. Okay, now in this case we are, this is a part of your unit 3. Okay, this small part I'm going to take. Okay, and they are my non-parametric tests. Now non-parametric test in the sense there is no separate parameter for comparing the data. That is what, if some data A and data B is given, okay, the data is compared directly, not like in this case that mean is calculated and then the mean is compared, or the variance is calculated and then the variance is compared. No. Okay, in this case directly one to one the data is compared. Okay, and such kind of tests are called as non-parametric tests. Okay, out of that we'll look for the first one. It is called as Mann, Whitney, U test. Now these tests are really simple. Okay, now I'll just go directly with the example. Now suppose two samples are given, x and y. Okay, now two samples in the sense this 64, 76, suppose 78, 75, 82, 28, 82, and 94. Suppose this is some sample A. Now these are the some observations of sample B. Let's say this 78, 95, 63, 37, 63, 77, 65, 74, 48. Okay, now need not be, the number of observations need not be same. Okay, so now what we are going to do is, in this case, how we are going to apply this Mann Whitney test, to what we are going to compare these tests. Okay, now what we are going to do in this case is that, now see, my first hypothesis is that these two data are of the same population. That is what, these two samples have very similarity then in it. That is, these two samples are similar. Okay, when we say that two samples are similar, that means what? We assume that they have come from the same population. Okay, that is they represent a same population. So that will be my first null hypothesis. Okay, and I will be testing that whether So basically, this Mann Whitney U tests, this test is used for checking whether the given two samples are coming from the same population or not. Okay, so my first null hypothesis, this will be same for all the problems of this Mann Whitney U test. Okay, the two samples are taken from same population. Okay, now this is my null hypothesis. Okay, so my what will be my H1, that is alternate hypothesis, the two samples are not taken from same population. This can be also true, or even another thing can be true, that they are taken from two different populations, or taken from different populations. Now, even in many some cases, a question can be framed like whether this represents this or this y represent this. So according to that, you can write this h naught. Okay, your null hypothesis can be framed in that way. Okay, I had explained this how to frame the null hypothesis and alternate hypothesis based on your examples. But if no data is given about that, then it will be like your h naught will be directly that the two samples are taken from the same population, especially for this Mann Whitney test. Okay, now, if this is my example, now I'll show how to proceed with this. Now h naught is done, h1 is done. Okay, next step is setting up of my level of significance. Okay, now in this case nothing is mentioned, therefore 5% or 1%, that we will decide, we'll check at both. Okay, so see, now these are the basic steps which we repeat in all the cases. Now from here the problem starts. See, the next step is, once you have this x and y, what you will do is you will combine both of these data. Okay, you will combine this x and you will combine this y. Okay, so see, and you will write it together, the combined series. So combined series. Now how you will write this? You will arrange these numbers or these data in the ascending order. Okay. So ascending order. So if you go to C, which one is the smallest number? The smallest number in this case, it belongs to this X, that is 28. So I will start with like this. Okay. Now I will just mention your sample value and a, yes, sample and a value. So this value is the smallest value and that belongs to my sample x. Okay, now after 28, which is the next value, which is the next smallest value? The next smallest value is 37 and that belongs to sample y. So from sample y I have 37. Now after 37, which is the smallest value? That is the 48. Okay, so 48, that also belongs to y, therefore 48. Now after this, which is the next smallest? That is 63, that also belongs to y. And after 63 it is again 63. Yes, there are two 63s in this cases, so both we will write separately and both are belonging to y. So I will mention this y, this 63, and from y it is 63. Both 63s are mentioned separately. Then after 63 there comes this 64. This 64 is from x. Okay, so 64 from x. Then after 64 comes this 65. Yes, and that 65 is from y. So 65 from y. Now after 65, what is the next value after 65? That comes out to be my 74 and that 74 is from y. So from y it will be 74. Now once that's 74, after 74, what is the next value? That comes out to be my 75. After 75, that is 76, both are from x value. Okay, so 75 and 76, both from x. Then after 76, what is the next? Is the 77 from y. Okay, so that is, I'll write this here, 77 from y. Then after 77, what comes? 78. Now 78 are there both in x as well as y. So I will write it again twice. Okay, 78 from x and 78 from y. Okay, now once 78 has been done, after that the next value is the 82. Again 82 is repeated twice and both from x. So I will write it again, 82, 82, and both from x. So I have written this. Now after 82, which is the next value? After 82, it will be 94. Yes. So 94, 94, that is again coming from x. And after 94, it comes out to be 95 coming from y. Okay. So these are the values we have taken. All the values have been covered. Now, if you go to see my sample size for x is my n1, and sample size for y is my n2. And let's see how many are there: 1 2 3 4 5 6 7 8. So n1 is 8 and n2 is 1 2 3 4 5 6 7 8 9. N2 is 9. Okay, so clearly in this case n1 is not equal to n2. Okay, so this Mann Whitney test, there is no restriction that both the sample sizes should be equal or anything. Okay, so this tells that both the samples are independent also, they are not paired or they are not dependent on each other. Okay, okay, so now this thing has been done. That is what my first step was. First step of the problem, that is after writing this h naught, h1, etc. First step is writing this all the values which I have collected from both the samples in the ascending order. Ascending in the sense increasing order. Okay, now once this has been done, okay, what I will do is I will allot some ranks to them. Okay, ranks in the increasing order. Okay, so my first rank to the smallest number here. Now which is my smallest number? Smallest number is 28, that is my 1, rank goes to 1. The next number is 37, so it gets rank 2. Third is 48, so it gets the rank 3. Now my fourth and the fifth numbers are 1 and the same, 63. So actually the rank should be some 4 and some 5. Okay, but now to avoid this, how I get write my rank? 4 plus 5 by 2, that comes out to be 4.5. That is the average of both these ranks. Okay, that is 4.5. So I allot 4.5 to this, I allot 4.5 to this. Okay, now next is, now 1 2 3, this is 4, this one is 5. Okay, so next rank is what? 6. I allot 6 to this 64. Then 65 will get the 7th rank. Next will be 8. Next will be ninth. Next will be 10th. Okay, then next here it will be 11th ranks. Okay, 11th. Then again there is a tie, 78 78. So this is the rank number 12, this is the rank number 13. And now since there is a tie, I will take an average of these two, that is 12 plus 13 divided by 2, the average of this, that is 12.5. So I will allot 12.5 to this, I will allot 12.5 to this. Okay, now next is, so that is now 12 and 13 are gone. Next rank is 14. Okay, but here again there is a repetition, 2 are there, therefore 14 plus 15 by 2. Okay, that is the average of these two ranks, that is 14.5 and 14.5. Okay, and then 14 and 15 are gone, therefore this is 16, next is 17. So now I have allotted the ranks to each and every value. Okay, so now what is my next step? This has been done. Next step is I will calculate something called as tx. Now what is or tx? Now what is this tx? Tx is the sum of ranks in x. That is what I will look here. Whatever these x terms are, this x, these are the from x, this is from x, this one is from x, this one is from x, this. I will say check all the ranks of them. Okay, that is for this first value 28, it is 1, then for this it is 6, then it is 9, then it is 10. Okay, and I will add them all. Okay, so what will be, that is the reason I have specially mentioned these x values here. Okay, so sum of the ranks in x will be 1 plus next rank will be, sorry, the next rank will be here, that is this 6. Next rank will be here, 9, then 10, then it will be 12.5, then it will be this 14.5 plus this 14.5 and this 16. Okay, all these things I will add. So 1 plus 6 plus 9 plus 10 plus 12.5 plus 14.5 plus 14.5 plus 16. Okay, these are my tx values, that is sum of the ranks in x, and this addition comes out to be 83.5. Okay, now similarly I will define my ty. Now once I have defined tx, you know what will be ty. Okay, it will be sum of the ranks in y. Okay, so now what will be those? The values of this. Now for y is belonging here, so it will be 2, then the value of this 3, 4.5, 4.5, then this value 7 plus 8 plus then 12.5 plus 17. Okay, so it will come out to be 2 plus 3 plus 4.5 plus 4.5 plus 7 plus 8 plus 11 plus 12.5 plus 17 is equals to, and this entire addition comes out to be 69.5. Now next step is tx and ty has been calculated. Now next step is calculating something called as ux. Now what is ux? Ux is defined by tx minus n1 to n1 plus 1 upon 2. Okay. Now tx I know very well, tx is 83.5 minus n1. What is n1? N1 is the sample size of this x. Okay, and that is n1 is 8. So I will substitute that value. 8 into 8 plus 1 by 2. Okay, and this ux value, if you simplify, you get this to be 83.5 minus this will be 36, and that comes out to be 47.5. That is your ux value. Okay, now similarly, now once ux has been calculated, you know how to calculate uy. Only x will be replaced by y, so ty minus, now in place of n1 it will be n2, n2 to n2 plus 1 upon 2. Now ty value we have calculated here, that is 69.5 minus n2. N2 value is what? N2 is the sample size of y, that is 9. Okay, so this comes out to be, n2 is my 9, then 9 plus 1 by 2, and this one will be 9 plus 1 will be 10. 10 divided by 2 is 5. 9 5s are 45. 16, so 69.5 minus 45, and this value comes out to be total of 24.5. Okay, so now you have calculated ux, you have calculated uy. Okay, so ux comma uy. Now what you will do is you will consider u as the minimum of ux and uy. That is what you will check for the smallest number of this uy and ux. Now which one is the smallest number? 24.5 is the smallest, that is uy is the smallest number. So u is your minimum of 47.5 comma 24.5, and that comes out to be your 24.5. So your u value is 24.5. Now, at this point, I will just give you a hint whether you are proceeding in a correct direction or not, that you can verify with this equation. Ux plus uy will be always equal to n1 n2. Okay? So, if this equation is satisfied, that means you are going in a, so far you are correct. Okay? This is the equation which will be satisfied. You need not verify this in the exam. Okay? Just for your understanding or just for your assurance, you can just try this if you have a doubt anywhere. Okay, so if you check in, even in this case this condition is satisfied. Now n1 is your 8, n2 is your 9, so this right hand side comes out to be 9 8s are 72. Okay, and ux plus uy, it is 47.5 plus 24.5, that also comes out to be 72. Okay, so that means this condition is satisfied in this case. Okay, you need not show this in the exam. Okay, okay, so now once you have calculated this u, my test statistic, I will just explain how to go for this test statistic. My test statistic is, and these test statistics will be using at many places for the further test also. Z is equals to u minus mean upon standard deviation. Now, in this case, the definition u is the thing which we have found, u is 24.5. Now, the definition of mean and standard deviation changes at these cases. Okay, now we'll explain how to find out this mean and this standard deviation, but I'll just brief you. Once we find this u, mean and standard deviation, we will calculate my z value, and based on that z value, whether it is crossing the critical value or not, we will accept or reject a hypothesis. This is the as usual procedure. Okay, so now for this, my mean will be, in such cases for my Mann whitney test, okay, my mean is defined by n1 n2 by 2. Okay, and standard deviation is defined by root of n1 n2 into n1 plus n2 plus 1 divided by 12. Now this 12 is not only because of this example, but this 12 is the formula. This 12 is from formula. Okay, so don't get confused from where this 12 has come. Okay, it is just the formula. Okay, so if I calculate this, my mean will be, now n1 is 8, n2 is 9 divided by 2, so that is 72 by 2, that is 36. So my mean value is 36. Now if I want the standard deviation I will get by n1 is 8, n2 is 9, n1 plus n2 plus 1, 17 plus 1, that is 18 by 12, and this value you will get to be, once you solve, it will be 10.39. Okay, and yes, what I forgot to tell you, this you have to consider the modulus of this z. That is what, only the positive value. Even if you don't write this modulus sign, it is okay. Okay, but you need to calculate the positive value which comes from this. Okay, so now I have found my mean, I have found my standard deviation. I will substitute in the formula of z. So in the formula of z, what will be my test statistic? Z is equals to u. U value is what? 24.5, which we have found. Okay, u we have calculated 24.5. Next is writing the mean. Mean was 36, which we found, divided by the standard deviation, that is 10.39, and when you are taking the positive value, this comes out to be 1 point some 1 or 1.106 something, that is 1.11. Okay, now if this is my calculated value, okay, now if I'm looking for this in the table which we used to see, okay, now at 5% level of significance, critical value is 1.96, and at 1% level of significance, my critical value is 2.58. Okay, this is for the testing of hypothesis area or the critical region area or the acceptance region area. Okay, so now if I test for this at 5%, my calculated value is less than my tabulated one. Yes, or the critical one, that is 1.11 is less than 1.96. Therefore, what I will do, my H naught, my null hypothesis is accepted. Okay, and also that is what they both are taken, both the samples are taken from the same population. Now, similarly, at 1% it is 2.58. Okay, so again, this calculated value 1.11 is less than 2.5. Therefore, again, H naught is accepted at 1% level of significance. Okay, so basically at both the levels of significance, this is accepted. So this is how you proceed with such kind of examples. So I'll just give a quick revision of this Mann-Whitney test. Okay. Now, this Mann-Whitney U test is sometimes even referred to as Mann-Whitney test itself. Okay, so just don't get confused. So now I'll just give a quick revision. That is, first step will be writing the null hypothesis H naught. Okay, based on the question, or otherwise it will be like both the samples are taken from the same population. Then writing the H1. Okay, exactly opposite to H naught. Then level setting the level of significance, either 5% or 1% or whatever is given in the question. The next step is both the samples. Okay, then arranging in increasing order or the ascending order. Okay, and then next step is allotting ranks to them. Okay, and now just remember these, when you are allotting the ranks, if there is a tie, the ranks are allotted as an average. Okay, then next step is, after ranks are allotted, next step is calculating tx is what? Sum of ranks in x. Okay, so only you are considering those values of x, all those values of the ranks which are given to the values in x. Okay, similarly you will calculate ty, that is sum of the ranks in y. Okay, now once tx and ty has been calculated, you will calculate ux is what? Tx minus n1 into n1 plus 1 upon 2. And similarly, you know what is uy, that is ty minus n2 plus 1 upon 2. Now, once this ux and uy has been calculated, what you will do? You will consider the minimum value of that. That is what? Your u will be minimum of ux sorry, u will be minimum of ux uy. That is the whatever minimum value you have, you will write. Now once u has been found out, what you will do, you will go for the test statistic z, which is given by u minus mean upon the standard deviation, and you are going to consider only the positive value of that. Okay, and mean is given by what? Mean is given by n1 n2 upon 2. Okay, n1 is the sample size of x, n2 is the sample size of the y. Okay, and similarly standard deviation is given by what? Root of a root of n1 into n2 upon n into n1 plus n2 plus 1, okay, divided by 12. This is the standard deviation formula. Okay, again I'm repeating, don't get confused within this 12 number, that how it has come. It is the part of the formula. Okay, now once you have calculated this mean and standard deviation, substitute both of these into this formula, and once this z value has been calculated, okay, whatever calculated value you have, compare it for the 5% or the 1% level of significance. For 5%, your critical value will be always 1.96, okay, and for 1%, it will be always 2.58. So, okay, so your calculated value is crossing these values, then what will happen? Your null hypothesis will be rejected. But if your calculated value is less than these values, okay, your null hypothesis will be accepted. Okay, so this is how we proceed with this kind of test.